This is a short movie to explain the principles behind Pythagoras' theorem. So if we take a right angle triangle, so just constructing one, and identify the right angle, then we know that there's a relationship between the sides of a right angle triangle. Now what Pythagoras discovered was that if you construct a square on the sides of the triangle, so I'm just drawing those in now, so there are the squares constructed on the two short sides, and finally let's put a square on the long side. Remember, the long side is called the hypotenuse. Okay, so what Pythagoras discovered was that if you calculate the area of this square, so one of the squares on the short side, and you calculate the area of the square on the other short side, and you add those together, you actually get the same answer as if you calculate the area of the larger square based on the hypotenuse. Okay, so let's have a look at how we could express that relationship, i.e. the areas of the squares constructed on the short side added together being equal to the area of the square constructed on the long side. Let's look at how we can express that in the well-known equation. So here we've got, if you like, a clean sheet. Let's just put our right angle triangle back in, and we'll label each of the sides now. So I'll label that A, B and C. Now of course the square constructed on the basis of this short side here would have an equation of A squared, i.e. the two sides of a square multiplied together would give you the area. Similarly, the square constructed on the side of B would give you an equation B squared, and the square constructed on the basis of C gives you C squared. And so we end up, if you like, with an equation which represents the relationship between the areas of those squares constructed on the sides of a right angle triangle, and we can use those, or we can use that relationship to help us identify unknown sides when we know at least two of the sides. Okay, this concludes this short movie. There'll be additional movies which will actually apply numerical values to Pythagoras' theorem.